Hey guys, it's Miss Coyle here. I'm going to talk to you a little bit about significant figures. So the numbers reported in a measurement are limited by the measuring tool. And so significant figures is the measurement of the known digits plus one estimated digit. For example, if you look at a graduated cylinder, let me draw my graduated cylinder up here for you guys. So and this is about 10, and I'm sorry, this is really hard to do, and this is about 9. You have your little marks in between. So I have in between the 10 and the 9, let me get a little bit closer, 1, 2, 3, 4. Okay, so this means this would be 9, 9.2, 9.4, 9.6, 9.8. So it looks like where I have my line drawn, it looks like it's about right at 9.6. The 9 is the digit I know for sure. That 6 is that estimated digit. I'm estimating what that is, especially with how horrible my drawing is down there. With the ones that we use in the classroom, however, you can usually estimate those a little bit further and a little bit more exact. So the first rule for significant figures is all non-zero digits in a measured number are significant. Only a 0 could indicate that rounding occurred. So in the case of 38.15, all 4 of those would be significant. 5.6, I have 2 significant figures. 65.6, no zeros, so I would have 3. Alright, they're going to write it for me. And in the case of 122.55, I would have 5 significant figures. So leading zeros and decimal numbers are not significant. So these numbers over here are never going to be significant. This 4 is, that's going to be significant. Okay? So in the case of 0.008 millimeters, that would have 1 significant figure. 0.0156, all 3 of those are significant. 0.42, that would have 2. And 0.00262, that would have 3 significant figures. So a lot of times people ask me, why are the zeros in front not significant? And the reason they're not significant is if you were considering these in scientific notation, which is how scientists usually do this. So let's look at the case of 0.008. If I wanted to put this into scientific notation, 1, 2, 3, so I have 8 times 10 to the negative third. You wouldn't include any of these zeros, so those are considered not significant. Zeros between non-zero numbers are significant. So in the case of 50.8, this 0 is significant. 2001, those zeros are significant, so that would be 4. In the case of 0.702, okay, we just talked about how zeros in front are never significant, but zeros in between are, so that would have 3 significant figures. And in the last case, again, these 3 zeros are never significant, but this one would be, so I would have 3 significant figures again. Trailing zeros and numbers without decimals are not significant. They are only serving as placeholders. So in my example of 25,000, for example, I would have 2 significant figures. These zeros are not significant. Why? That's an estimate. You're estimating that it's about 25,000 inches. If you measured it exactly to 225,000 inches, you would put a decimal point at the end, which is what they're doing this 200 point years. So all 3 of those would be significant because there is a decimal point there. In the case of 48,600 gallons, that appears to be an estimate. So these zeros are not significant, so I would only have 3 sig figs. In the case of 25,005,000 grams, these zeros were counted because I have that little 5 there, but these 3 zeros were not counted, so those are not significant. Those are estimated. So I have 1, 2, 3, 4, 5 significant figures. So which answer contains 3 significant figures? In A, B, all the zeros are significant. in which one of those? And 534,675 are rounded to 3 significant figures. So I'm going to give you a minute to go ahead and think of those. Alright, hopefully you've come up with an answer for all of these. So which answer contains 3 significant figures? That would be 2, and that would also be 3. All the zeros are significant in 1, the zeros would not be significant in the beginning. 2, these zeros are significant. They occur after a decimal and after a number. And in 3, all of these zeros are significant too. A good rule of thumb for scientific notation is anything that's written out. Move this up a little bit. All these numbers written out, these would all be significant. And that's how it's always going to be for scientific notation. So scientific notation is actually fairly easy figuring out how many significant figures you have, because it's what's ever written that's not the times 10 to the 7th. And in C, 534,675 rounded to 3 significant figures would be this number down here. You can't do 1 because 534 is a lot different than 534,675. Imagine that as money. Which one would you rather have? $534,000 or $535? 5.35 times 10 to the 5th, if I look at my scientific notation, 1, 2, 3, 4, 5. That is the number given here, so this one would also work. In which set do both numbers contain the same number of significant figures? Go ahead and take a minute to figure this out, and then I'll go over the answer as well. Alright, which one contains the same number of significant figures? A, I have 3 sig figs. Over here I have 4. In this case I have 4 significant figures and 1. In this case none of those are significant, but these two are. These two are significant and none of those zeros are. So your answer would be 3. State the number of sig figs in each of the following. Go ahead, take a moment to figure that out, and then I'll go back and go over the answers with you. Okay, A, these zeros are not significant at the front. This 3 is, and this 0 is significant. Remember, in order for a 0 to be significant, there has to be a decimal place present, and it has to occur after a non-zero number. So there must be a decimal place present, which there is, and it has to occur after a non-zero number, which it is. So that would be 2. B, 4.050 liters. These 3 are all significant. This 0, there's a decimal place present, and it's occurring after a non-zero number, so all 4 of these would be significant. C, zeros in front of the number never count. There's a decimal place present, but these zeros are not occurring after a non-zero number, so that would just be 1. D, 3.00 meters. All 3 of these are significant. There's a decimal place present, and they're occurring after a non-zero number. 2,080 million. These 3 are all significant. These are not, because there is no decimal place present, so that would just be 3. Scientific notation calculations. I'm going to have another recording for this.